around you. Cloth hangers, hands of a clock, food items like slice of pizza. There are so many examples of angles that you don't even realize. Any motion in 2D or 3D, whether being solved by human brains or computer brains, angles are everywhere, since nothing moves in a straight line. Angles are an integral part of our lives. Why do we need to learn angles? They are used in a variety of disciplines. Angles are important in studying polygons like triangles and quadrilaterals. Here in this video, we are going to discuss the basic aspects of angles and their units. Before dealing units of angle measure, one should know what an angle is. Angle is a measure of rotation of a given ray about its initial point. So, in this figure, angle formed is BOA. Alright? Now, consider this figure. The original ray is called the initial side and the final position of the ray after rotation is called terminal side. In other words, we can say the measure of an angle is the amount of rotation performed to get the terminal side from the initial side. Now, let's see how the direction of rotation and angle is related. If the direction of rotation is anti-clockwise, we can say the angle is positive. While on the other hand, the angle is said to be negative if the direction of rotation happens in the clockwise direction. Let's see the diagrams for better understanding. In the figure, you can see the point of rotation which is called the vertex. Here, point A is the vertex. This is a positive angle since the rotation is anti-clockwise. While in this figure, the direction of rotation is clockwise, so therefore it is a negative angle. Usually, unit of angle measure is taken in terms of revolution. One complete revolution means one complete turn around a circle. Other units of angle measures are degree and radian. Let's discuss one by one. First one, we will discuss about degree measure. A measure of 1 degree is equivalent to a rotation of 1/360th of a revolution. A degree is divided into 60 minutes. So we can write it as 1 degree is equal to 60 minutes. Now, a minute is further divided into 60 seconds. So that is 1 minute is equal to 60 seconds. Or we can say 1/60th of a minute is called a second. Similarly, one can say 1/60th of a degree is a minute. To measure the angles, it is convenient to mark degrees on the circumference of a circle. As you can see on the screen, various angles are marked. 30 degree, 45 degree, 60 degree, 90 degree and so on. As you can also see, 360 degree makes one complete revolution. Alright. Next we will discuss about radian measure. Radian measure is nothing but it is the measurement of angle related to the radius of the circle. So we can define 1 radian as the angle subtended at the center by an arc of length 1 unit in a unit circle. So let's see diagrammatically. Radius of 1 unit is marked here. Then the arc length of 1 unit is also marked and the angle subtended at the center will be 1 radian. Let's see some angles whose measures are 1 radian, minus 1 radian, 1.5 radian and minus 1.5 radian. Since the circumference of a circle of radius 1 unit is 2 pi r, one complete revolution around a circle corresponds to an angle of 2 pi radians. Because L by r is equal to 2 pi r by r. So we get 2 pi radians. Let's discuss radian measure formula. Generally, in a circle of radius r, an arc of length r will subtend an angle of 1 radian. An arc of length 1 will subtend an angle of 1 by r radian. Therefore, an arc of length L will subtend an angle of L into 1 by r, or we can say L by r radians. If theta is the angle subtended at the center, we know equal arcs of a circle subtend equal angles at the center. Therefore, theta is equal to L by r. From this we can write L is equal to r into theta. And this is a relation connecting arc length, radius and radian measure. Now, let's discuss relation between radian and real numbers. Consider the figure. It is a unit circle with center O. Then what is A? A is any point on the circle. Now OA is the initial side of an angle and the line PAQ is the tangent touching at point A. So we got a line and a circle. Alright. Now assume point A represents the real number 0 and the length AP represents the positive real numbers and AQ represents the negative real numbers. Now if we try to rope the line AP in anti-clockwise direction and AQ in clockwise direction along the circle, surprisingly we can understand every real number corresponds to an radian measure. Thus, radian measure and real numbers can be considered as one and the same. So we have learned the various units of angle measure. Measurement of angles can be performed using radian measure and degree measure. Now we can derive a relation between degree and radian so that the conversion from one unit to the other and vice versa can be done very easily. Let's see the derivation. We know a circle subtends an angle of 2 pi radians at the center. We also know one complete revolution makes 360 degree. Now connecting these two ideas, we can write 2 pi radian is equal to 360 degree. Or from this we can write pi radian is equal to 180 degree. Therefore, 1 radian will be 180 by pi, which is equal to 57 degree 16 minutes approximately. Also, 1 degree is equal to pi by 180, which is equal to 0.01746 radian approximately. In general, we can write radian measure is equal to pi by 180 into degree measure, and the reverse, degree measure is equal to 180 by pi into radian measure. These two relations help us to express a radian measure in terms of degree measure and vice versa. Now, let's see the relation between degree measure and radian measure of some common angles. Here we have to multiply each degree value with pi by 180. So, 30 degree is equal to pi by 180 into 30 and we get it as pi by 6. Similarly, we can find the radian measure of any angle. Let's have a look at this table to know the radian measure of a few common angles. For the degree 30 degree, the radian measure is pi by 6. Just we have found it now. Now 45 degree corresponds to pi by 4. 60 degree corresponds to pi by 3. 90 degree corresponds to pi by 2. What is 180 degree? 180 degree will correspond to pi, and the last 360 degree corresponds to 2 pi radians. Let's see one example for better understanding. Convert 75 degree 40 minutes into radian measure. We know 180 degree is equal to pi radians. We need to multiply the given degree measure with pi by 180 in order to convert it into radians. Alright. So 75 degree 40 minutes is equal to 75 2 by 3 degree, because 1 minute is 1 by 60 degree. Therefore, again multiplying with pi by 180 we get 75 2 by 3 degree is equal to pi by 180 into 227 by 3, which is equal to, we get 227 pi by 540 radians. Now that we have learned all fundamental aspects of angles, let's now extend the definition of angle in terms of radian measure to the trigonometrical ratios and study them as trigonometric functions, which we will find out in detail in the coming video. Now it's time to sum up the entire section.
Manorama Horizon, learning made simple.